the AutoSense OS operating system is one of the key competencies of Phonak, and we wanted to provide evidence-based science to show that the Phonak system is the best out there. We had 3 different manufacturers' devices that were involved in this study, and we have done everything possible to ensure that robust scientific methods were applied. We took these hearing aids out into the real world and measured how they performed in settings that people encounter every day.
We always want to start with a technical measurement phase with Kimar, our acoustic mannequin, in the sound booth.
The best stop on our trip was Bolnevo. A religious festival was going on.
We wanted to make sure that the hearing aids were doing exactly what the manufacturers say they're supposed to do, which is adjust to the sound scene. And so the technical measurements were designed to determine that that really was the case. We wanted to test the hearing aids in different real-world, noisy situations. The coffee shop, a car, and our acoustic listening loft that we have here at the Research Center.
We took sound level meters out to all the scenes to measure exactly what the background noise was and what the speech levels were that we wanted to present. And then we could ensure time after time that those levels were always maintained consistently. The recorded IEEE sentences were presented from the same speaker in each of the scenes. We calibrated the level of the presentation according to what we believed would be ecologically valid for that scene. The speaker was always in the exact same position for each test. The orientation of the participants and the speaker in each scene was also always carefully controlled. When we initially fit the subjects with the hearing instruments, we performed real ear measures and fit them all to NAL, NL2 targets to eliminate any variations that would have occurred in audibility. So the baseline starting point for each device was essentially the same program. We tested 15 subjects. We took them into 4 different environments, and in each environment, they wore 3 sets of hearing aids. They did 20 sentences for each of the 3 hearing aids in each of the 4 scenes. We had 3 research audiologists that were along for the entire ride.
The wide road shimmered in the hot sun.
The wide road shimmered in the hot sun.
My job is to switch out the hearing aids and replace them. And each hearing aid has an acoustically transparent cover, and it's opaque, so nobody knows which hearing aid is going into the patient's ear. I'm the only researcher here that knows the order of the hearing aids, and the order of the hearing aids was generated by a random number generator. Before we start scoring, we allow the test to run for about 40 seconds, and that gives enough time for the hearing aids to adapt.
This will lead the world to more sound and fury.
This will leave the world in more sound and fury.
My role for this scene is to hold the wireless speaker at a consistent height and distance from the participant.
In the car, we did everything that we could to ensure that each participant experienced the exact same conditions. So we used the same car on the same road with the same pavement. We had the ventilation system set at the same level. We controlled the level of the background noise babble that was coming through the radio. We controlled the placement of the speaker. We drove at the exact same rate of speed for each participant.
Look in the corner to find the tan shirt.
Look in the corner to find the tan shirt.
I have the 3rd job of the researchers. I'm the scorer. So I listen to how the participant repeats the sentences and record what words they got correct. I know that I can hear the participant accurately because we're using a Roger-focused wireless system. The participant wears a microphone and I have a miniature receiver in my ear so that I'm sure, even though I can't always look up and read lips, that I've heard him accurately and am documenting his responses correctly. When we talk to people with hearing loss, they tell us they want to hear consistently and automatically again. We believed that there was something special in how AutoSense OS was able to adapt and blend to optimize hearing across a multitude of real-life and complex environments. And we wanted to test that against the competition. And we wanted to do it in the most rigorous and scientific way possible. So that's the study we designed, and we went out and did it.